So before we get into the memory technology, for those of you who may not be that familiar with Open Silicon, just going to spend a couple minutes here talking about the company. We were founded back in 2003, so we just experienced our 10th year anniversary celebration back in April. Very proud of that. We're based in Milpitas in Silicon Valley. And the focus of our company fundamentally is ASIC development, ASIC design, and we do that very collaboratively, working with our customers, starting at architecture specs, RTL. Most of our designs are netlist, RTL, and handoffs like that, and we do a lot of the back-end processing, physical design, package test, and produce ASICs, including running production silicon for our customers. We have 9 global engineering and support centers, and we've done over 300 design projects in the last 10 years, shipped over 75 million ASIC units during that period of time. We do have IP. Most of what we do for our customers is working with third-party IP. So we actually leverage very heavily the ChipEstimate design portal for helping our customers select and evaluate third-party IP. But there's a time to time that comes when there's certain kinds of IP that is not available readily on the open market. And that's where things that I'm going to talk about today come in. And besides providing IP for our ASIC customers, we do have a straight-up IP licensing model where you can come to us and license IP directly like any third-party IP provider. So jumping into the memory technology, what I'm going to talk about is something called hybrid memory cube. And before we get into the technology itself, we're going to talk a little bit about this graphic here on the left. On the left-hand side, this chart shows a couple of things. One is the current trending in terms of performance and as well as power and reduction in power in DRAM technology. And what a lot of people will say is that there's a memory wall that's going to be hit here. And that is that there's a slowing in the improvements of performance and a slowing in the improvements of power and reduction of power in the DRAM business. At the same time, resolving bits within a high-density DRAM array is becoming more challenging, similar to like in flash technology, where it takes more intelligence to actually resolve bit definition. So a memory wall is quickly approaching us, and Micron was the first company in conjunction with Intel Labs to come up with this technology, and now it's being adopted by a consortium I'll talk about in a minute. So this technology, hybrid memory cube, actually combines advanced packaging and 3D silicon techniques where they're taking DRAM die and stacking them one on top of the other and then stacking that stack on top of a logic layer or logic device. And all of that is using something called TSV or through silicon via. So it's active TSV technology. It's very advanced. It's the latest in 3-dimensional silicon fabrication technologies. Not to be confused with FinFET and 3D transistors. This is actually 3D packaging. The net result of hybrid memory cube technology is a drastic reduction in power in terms of the energy per bit required to store and transmit information. There's also a greatly reduced footprint. The size of a hybrid memory cube is roughly in the order of a 20 by 20 or 30 by 30 BGA package. And then the bandwidth itself is really the astronomical leap forward in terms of bandwidth. If you can envision a 30 by 30 BGA, which is, I don't know, about the size of 2 thumbs on your hand, that has the same bandwidth as 15 memory DIMM modules. So you could talk about, something about 8 by 11 for 15 DIMMs has now been compressed into a 30 by 30 BGA package running at a fraction of the power. And that's what hybrid memory cube technology is. So hybrid memory cube is actually being developed, and the interfaces that are interfacing to hybrid memory cube technology are being developed through a consortium we call the Hybrid Memory Cube Consortium. You can check out the consortium at hybridmemorycube.org. There are over 100 members participating in the Hybrid Memory Cube Consortium. It's growing rapidly every day. And within the consortium, there is a small set of developer members, of which Open Silicon is a member. You can see them here on the lower left. But the function of this group is really to define, from a system standpoint, from electrical interface and a protocol standpoint, how do you interface to this next generation technology? And the technology is being embraced by all the major DRAM providers, Samsung, Micron, and Hynix. The Hybrid Memory Cube Consortium actually ratified and released the first public version of the specification in late Q1 this year. So thanks to Micron, who provided these nice graphics, here's a kind of a graphic and showing you the type of topologies in terms of system memory you can build with hybrid memory cubes, as well as where it might be useful. So on the left here you have what's termed near memory, which is taking the highest bandwidth memory and connecting it directly to a host CPU or GPU or ASIC. This is really good for things like high performance computing or high density servers, where you have CPUs and GPUs. Could be used in high-end graphics where you've got a very high bandwidth requirement. And I haven't talked about the bandwidth. Let me just hit this a little bit. We're talking about bandwidth, like I said, is about 10 to 15 times what's capable of a DDR3 module. So that's in the order of about a terabit and a half per second of memory bandwidth. So way, way up there in terms of leap forward in terms of bandwidth. High-end networking, wireline networking, as well as test equipment for trace buffers and things like that really fit well with the near memory configuration. For some applications, primarily server applications, where you have to have both high bandwidth as well as greater memory capacity, we're talking about in the initial cubes coming out 2 gigabyte or 4 gigabytes worth of DRAM capacity at these bandwidths. You can go with a far memory where you can have different topologies. This one here shown as sort of a cascaded or a type of a star topology. But there are 4 links on the memory cube, and you can interconnect these in different ways to processors and with each other. So this gives you really much more of a scaling capability while still maintaining very high bandwidth. So I said earlier, primary business for Open Silicon, developing ASICs collaboratively with our customers. But we are offering IP. Open Silicon is offering hybrid memory cube controller IP, similar to a few other IP cores, which I'll review in a minute. But this is what we're debuting today, and this is our HMC controller IP. This is soft synthesizable RTL core that would go inside your ASIC or your CPU. And it's pretty standard in terms of the deliverables that you get. On the outbound side, the outside of your chip, you would connect this controller core to a SerDes. It would be a third-party SerDes from a number of providers that we work with. Or on the inside, or the user side of this, you can have a native interface or an AXI 4.0 interface. It's fully compliant with the HMC Consortium specification that was released. We support within this controller from 1 to 4 HMC links. Each cube has from 1 to 4 links, and the links themselves run in either a by 8 or a by 16 mode. Link speeds are from 10 gigabit to 15 gigabits, and the aggregate bandwidth across the hybrid memory cube in terms of peak at 15 gigabits is all the way up to 240 gigabytes per second. We're offering this in both ASIC and FPGA versions. This is the first time for Open Silicon actually to embrace more of the FPGA market from an IP standpoint. We have offered FPGA cores in the past. This particular core has actually got a redesigned pipeline that's wider to go with the FPGA technology. And both the FPGA and ASIC cores are available today for design-in. Because this is dramatically new, revolutionary technology, we realize that our customers are going to require some means for evaluating the technology. That means what performance, what latency, what bandwidth, what power is really achievable when you're building a system like this. So for the first time ever, to help our ASIC and system customers, we're actually providing an evaluation platform based on Xilinx Vertex 7 FPGA. And this will come with, the FPGA board will come with not only our IP in it, but it also comes with some generators and monitors, as well as some software and a graphical user interface allow you to change the way the transaction works so you can evaluate the power and so forth. Comes in a PCI Express form factor with USB control, and we'll add the PCI Express control. Primarily here, this is focusing on evaluating the technology. This is in development now, will be released later this summer. So in addition to hybrid memory cube, when you think about hybrid memory cube and you talk about wireline data networking applications, what we're really trying to do is we're trying to augment the third-party ecosystem for IP by doing some important IP that our end customers typically use. So when you look at a wireline solution, you'll see packet memory, lookup memories, you'll see a system interface to chip, and you'll also see the line side interface connecting to the network. So Open Silicon provides a few other IP cores. This is Hybrid Memory Cube, and what's up here is what we focus on in addition to our ASIC business. So we offer interlocking, which is a chip-to-chip and also a lookup high-speed protocol. And that would be used for talking to ternary cams as well as talking to other chips. We're the #1 licensee for interlocking IP protocol IP in the industry. We've licensed to over 45 different licensees. We also have some Ethernet MAC and PCS technology. Both backplane technology in the wireline as well as network interfaces are growing rapidly into the 40 gig and 100 gig space. And so we're offering both 40 gig and 100 gig MAC as well as some universal MAC technology. So when you put it all together, we actually have, for our ASIC customers, the ability to help them assemble a pretty complex high-end networking, wireline networking solution or network processing solution. So to kind of wrap it all up, we're one of the founding members of the HMC consortium. This is a very revolutionary new DRAM-based memory technology. We're offering both the ASIC and FPGA controller IP cores that are available today for design-in. We're certainly very willing and open to helping you use our IP to produce ASICs and develop ASICs. We've got a vast array of experience in serial connectivity, integrating high-speed serial interfaces. And for the first time, we're actually going to produce some FPGA evaluation boards that really help kickstart this new technology into the market. You can find out more about us at opensilicon.com, and certainly please do visit the hybridmemorycube.org and check out the consortium as well.
Questions? Hold on, right?
What kind of lead time do you need for my IP configuration?
For your IP configuration, it depends on, it depends. If it's something that we've already configured, number of lanes, number of links, could be very quick. It could be just a couple of weeks if it needs to turn. So the interlocking, if you're familiar with interlocking, is vastly configurable IP. It can take us several weeks sometimes to put together configuration. HMC is actually fairly straightforward. So depending on your configuration, it could be turned in a couple of weeks.
Another question? We want everyone to hear your wonderful voice.
LPDDR, any plans for that?
No, for LPDDR, we're sticking with leveraging what's out in the third-party ecosystem in the community. Really, for Open Silicon, what we're trying to do is fill the void in specific spaces where our customers can't easily locate third-party IP. For third-party IP, we work very closely with ChipEstimate to try and bring together end solutions.
I don't know if you covered this. How broadly is the memory cube used, and what are the end user applications?
That's a good question, Sean. So the memory cube technology is just beginning to sample. It's been, in terms of broadness, there are about 110 adopters within the consortium. So there are a lot of system companies ranging from test equipment to servers, big data, analytic type companies looking at it from a high performance computing standpoint, and certainly data networking would be. So primary applications would be high-end wired data networking, high performance computing, and test equipment is where we're seeing the initial adoptions.